Hi everyone, this is Vishal back again, and we are again discussing the problem of designing Gmail. In the past video, what we discussed, we were given a very ambiguous problem and we turned that ambiguous problem to something we can be more clear of. We reduced the scope, we discussed about scale, we did some assumptions. Now, after we have done some assumptions, we have known the scale, we actually want some numbers at our hand. We as engineers need concrete numbers. And if you have concrete numbers, you can design a system at a very good level. And for a system like Gmail, you definitely need those numbers. Okay? So, as part of this lecture, we will be discussing about two things. One is API design, and once we have designed our APIs, we will discuss about estimations. Right? Now, why are we designing the APIs first and then doing the estimations? Because once we know about the APIs we are going to support, only then we can estimate their QPS, scale, storage, and a tons of other stuff. And remember, I'll tell you how to design APIs. I'll tell you using your APIs, functional requirements, non-functional requirements, how to go ahead with the estimations. Okay, so let's begin. So usually most of our APIs come from the functional requirements we are going to support as part of this system, as part of this application. So let's start with the APIs we want to support. So we might want to support a send email API, right? Now, what would be a send email API? Definitely, it would be a post API, and its API signature could be something like we mention the version of the API and we mention the messages. So we have a post API that's available to send email for the clients, and definitely it's a write API. Now, what is a write API? A write API is something when we are writing something to the system. Let's say updating our database, adding a new record to a database. In this case, we are sending an email. That's a new email transaction. When I say an email transaction, it means someone sends an email to another. That will be updated in our system, or a new record would be added to our system. That's why it's a write API. What is the other kind of API we want to support? Read email, or I would say read or fetch email, right? Now, what kind of API is this? It is a GET API, and it's a GET API for, let's say, we want to tell about the message ID we want to get, right? And then finally, it's a read API. We are just reading a message that's already there in our DB. We're not writing or adding anything to our database. What all functionalities we have said we would want to support? We want to search emails, right? So that could be one of the API we would want to support. And what is this sort of API? It would be a GET API for sure, and its signature would be something like, let's say this is our version, and one second, this is our messages, and then we want to send the text based on which we want to search. Definitely, see, I have made this API very simple. but it could be the case that these APIs could be complex with pagination support available. So just for the sake of interview, we could keep it simple and mention that these APIs might have pagination. Definitely, it's also a read API. What all else API we want to support? We might want to support fetching folder details. Definitely, it will also be a get API, and its signature could be something like based on a folder ID. We want to fetch its folder details, and definitely it would be a read API. We are just fetching the folder details. We are not updating the folder details. We also might want to fetch folder messages, all the emails in a given folder. Definitely it's a get API. And what could be its possible signature? We have a version, we have a folder, and let's put it to other endpoint, and we have passed the folder ID. We have to search the messages with the given folder ID. Okay. Now that's also a read API. Having said that, these are, let's say, there could be other APIs as well, like update folder and a lot of other things, add new folder, right? But let's take only these 5 APIs, because we also have to think about the time we have in the interview. Now, based on this 5, the interview judged your skills to actually design APIs, classify APIs whether it's a read or a write, classify API whether it's a get API or a post API, classify or make the API signature. And definitely the interviewer is also judged that you know the importance of defining the API structure as part of your system design. Now, we have the APIs in hand for us, right? We want to estimate a couple of things for a system. While we are estimating for a system, we usually estimate 2 things for a system. What is the QPS requirements and what is the storage requirements for the system. QPS actually stands for queries per second, and storage actually stands for storage space required across various databases we might need. Okay. Now QPS in itself could be of 2 types. Read QPS, like out of the read queries, what are the queries per second for read queries? Like how many queries are we receiving in 1 second for the read queries? How many queries per second we are receiving for the write queries? These are the 2 things we estimate. Okay. So let's add bullet points for them. These are some things we want to estimate. So definitely we have a lot of read APIs, but let's focus on the very important read API that we definitely call, that is fetch an email. Right. Now here will our assumptions and our APIs will help us. We went ahead, okay, other are also read APIs. First of all, we knew that these are the 4 read APIs we are going to support. These are not that very important, because the core functionalities we want to work upon are send email and receive email. So let's focus on this API. Okay. So how do we actually calculate the read QPS? So we actually calculate the read QPS by total number of queries in a given time divided by time in seconds. So this actually gives us total number of queries in 1 second. So what are the total number of queries? Let's take the time as 1 day, and let's solve this formula. So let me put it here. This is the formula for calculating the QPS. So if we are solving for read QPS, we'll actually calculate total number of read queries over time in seconds. So let's here take time equals to 1 day equals to, so how many seconds are there in a day? So we have 24 hours, each hour has 60 minutes, each minute has 60 seconds, so these are 86,400 seconds. Can I approximately write it as 10 power 5? Yes. So let's say the time we are taking equals to 1 day and it has 10 power 5 seconds. Right. Now let's estimate our read QPS. So within 1 day, how many read queries we receive? Okay. So we have 1 billion users. That's 10 is to power 9 users. Each user receives 40 emails in a day. So each user makes this query 40 times. Right. So 10 is per 9 users and 40 times he call it them. So in 1 day, these many read queries are made. How many seconds in 1 day? 10 power 5. So what is a read QPS? It's 400k or 4 lakh is the read QPS for this query required by Gmail. Let's estimate the write QPS for this problem. So what are the total number of write queries? So there are 10 power 9, like 1 billion users. Each user actually sends 10 emails. We have assumed here. So these many write requests are there whenever email is sent. And 10 power 5 seconds in a day. So there are, it's like 100k write QPS is something I need. So 400k read QPS and 100k write QPS. And that's, to be honest, it's very huge. That's required to be supported. But now we have an idea, like we need to scale our system to a very huge scale because we need this much amount of queries per second hitting at our backend system, right? Now let's estimate about storage, right? So before going and estimating about storage, let's see, just a second. I just wanted to highlight very important stuff so that while you're revising, you just understand that like these are very important stuff to do. So before estimating about this storage, we actually want to see what all we are going to store. So definitely we are going to store all the emails, right? We are going to store all the emails. What does an email has? An email has a metadata. Now what is metadata? Body of the email, subject of the email, sender receiver details like who are all in the CC, BC and other lists. And in addition to metadata, an email could have an attachment. This attachment could be an image, video, file, zip, it could be anything. So we want to store these things about email. Definitely we would want to store other things like folders, user metadata, but those things won't amount for much, right? So let's focus on these core things for now and estimate their storage requirements, right? So how much metadata we need to support in 1 year? So let's define storage required in 1 year. Usually we actually estimate the storage required for the entire 1 year. Here the QPS for a given second, like in 1 second how much queries are hitting our backend systems. Here we are estimating how much storage is required for entire 1 year. That's the difference. Understand here, right? So let's estimate here. Okay. So we imagined that on average, size of a single attachment was 500 KB and size of a single email metadata is 50 KB, right? So sorry. So let's imagine we have 365 days in an year, and on a given day we have 10 power 9 users. Each user sent 10 emails, and each email has a size of 50 KB. So this much size of data is required to store in 1 year. Now, what is the size of this data? We'll see. I'll actually solve this further, but before solving it, I'll give you a trick. But let's before that solve the same solution for the attachments. So we have 365 days in a year, and each day we have 1 billion users, each user sending 10 emails, and let's say each email has a 500 KB of attachment. So this much size of attachment is required to be stored in 1 year. Now I will tell you like how much size you have to estimate here, right? But before that I want to show you something. Let's say you have and this trick will be useful to you to actually do these calculations fast in your interview. You have some x KBs of data, and you go ahead and multiply it with 1000. It become x MBs, right? Now you go ahead and multiply it with 1000. It become x GBs. Now you again go ahead and multiply it with 1000. It become x TBs. Now you again go ahead and multiply it with 1000. It become x PBs. So it's KBs, megabytes, gigabytes, terabytes, and petabytes, right? Now you can say that x KBs of data is multiplied with how many tens power are there? 10 power 3, 6, 9, 12. If multiplied with 10 power 12, it become x petabytes. Can we say that? Yes, we can say that because of this math I explained to you. Now let's see how much 10 to the power we have over here. It's 10 is to power 9 into 10, 10 is to power 10. Let's take two powers from here. 10 is to power 12. So it actually becomes, and 50 into 3, 150. So we have 150 into 10 power 12. How I actually computed it, I'll just explain you more. So 10 is per 9, 10 is per 10. So I can say that 300. I can take an approximation here. I can take 365 as 300. 10 is per 9, 10 is per 10 into 10 power 10 into what? Into 50, and that is a KB. Can I reduce that into 10 per 12? So I can say that 10 power 12, and what are the remaining? It becomes 150 KB. And we know 10 is per 12 KB is petabytes. So it will be 150 petabytes of metadata, email metadata is required to be stored. That's a huge data requirement we have to serve. So that's where now you will use a database that can support this much volume of data You might want to do partitioning on your data. You can't use a single node for storing your entire data, right? So that's where, and to be honest, this is just one record for a data set. You might want to do replication as well, which we have not taken into account for it. So that's where now you understand you need a very scalable database solution to meet this scale. Okay, let's see how much size of attachments do we want to store, right? So we can do the same thing. I'll be a little bit quick here. This is 10 to the power 9, 10, 11, 12. So we usually have 1500 petabytes, around 1500 petabytes. I could be off a little bit of attachment requirements that we want to support here. Now you see, like we need 10 times, and here also replication is not considered here, right? So replication would also come. So this is a very huge scale, both from the query API QPS and both from the storage requirements that we want to support. So that's all, guys. I actually wanted to cover the API design and the estimations as part of this section. So stay tuned, guys. In the next video, we'll go over the very high level component diagram and two design flows, sending email and receiving email. Thank you very much. Bye bye.